Okay, good morning, students. Welcome back to lesson metallurgy. We are in the third class. In our previous classes, we have learned about the metallurgy, various branches of metallurgy, and the various stages involved in the extraction of the metals. Now, in this class, we are going to learn about that is the principles of metallurgy. In this class, I am Gurumurthy. ZPS Critical is going to take the class for you. Now let us see what topics are going to be covered in this class. So in this class, we are going to learn about the extraction of the moderately active metals. In our previous class, we have learned about the extraction of the highly reactive metals from their ores. In this lesson, you are going to learn one important topic, that is thermite reaction. It's very, very important in the examination point of view. Hope you will pay a maximum attention. Okay, if time permits, we are going to learn the extraction of the low reactive metals also. Now, let us get into the lesson directly. As usual, I extend thanks to our DO sir and secretaries of the DCEB Khammam and DCEB SURYAPET. Now, let us see first what we have learned yesterday. Let us try to recall. We started with the froth flotation method. This is also a method of dressing in the ore or concentration of the ore, particularly the ores like sulfide ores are dressed in this froth flotation method. This is all about the froth flotation. A froth is formed with crude ore, forms a froth, that is a layer of bubble, and the impurities are settled down. By this way, we can separate the froth in terms of crude ore powder in the form of a powder. So this helps us to concentrate the ores in the form of sulfides. Then magnetic separation method also we have learned in our previous class. That is, if the ore contains the impurities in the form of non-magnetic material, then this method is magnetic separation method is very useful. The ore is powdered, pulverized into a fine powder and allowed to spin around the magnetic wheel. Then what happens? The non-magnetic material is separated, thrown away, and the magnetic ore is collected separately. Like this, we can separate or concentrate the ore which has the characteristics of the magnetic material. This is all about that we have learned. And also importantly, we have learned about the activity series. Based on the activity nature, reactivity nature of the materials, we arranged the metals in their decreasing order of reactivity. Some are high reactive, and some are moderate, and some are low reactive. Based on this nature, reactive nature, different methods are used to extract the metals from their ores. So high reactive metals are extracted in some other method called electrolysis. For electrolysis, first the ore has to be converted into its molten state or fused state. Then only the electrolysis will be easy and will be economically feasible. This is the chart that we have seen yesterday. Generally, let us recall once again, as it is a very important point. Metals exist in the nature in the form of compounds. They are called as minerals. From minerals, which one is best conveniently and economically feasible? That mineral is called as ore, that we have learned already. The ore or a mineral can exist in the form of oxides, chlorides, sulfides, carbonates, and etc. By the method electrolysis and a chemical process or a displacement for different reactive ores, we adopt different methods. So actually metals are in the form of +1 valency, +2 and +3 valencies. When the ore is undergone the chemical reaction named reduction, we get the raw metal from the ore. By the process of reduction only, we can extract the metals from the ores. This is all about we have learned in our previous class. So these are the steps involved. Based on the reactivity of the metals, we can adopt different methods for different ores. Now, today we are going to learn about the extraction of the metals in the middle of the activities. First of all, let us recall what type of metals comes under this middle moderate reactive metals. What are those? Here you see zinc, iron, lead, copper, and tin, that is tannum, are the middle moderately reactive metals. So we have to extract them from the ores. So what are the steps involved in this? Let us see this classification. Actually, moderately reactive ores available in the nature, that is in the earth crust, in the form of carbonates and sulfides, like zinc sulfide, iron sulfide and iron carbonate, lead sulfide, copper pyrites, copper sulfide, that is, and tin carbonate and tin sulfide. So the first step of extraction of the carbonate and sulfide ores is they have to be converted into oxide form by means of roasting or calcination. So we will learn about what is roasting and what is calcination in the course of our teaching, our class. So after converting these carbonates and sulfides into oxides, reduction process, the chemical reaction called reduction takes place. We reduce the oxide compounds into the metals. Why? Because it is very easy to reduce the oxide than the compound in another form like carbonate and sulfide. We first convert these compounds, carbonate compounds or sulfide compounds, that is carbonate ores or sulfide ores, into the oxide. Then it will be a easy process. Easily we can reduce the metals. That is why the carbonate ores and the sulfide ores are converted first into the oxide. Then these oxides are reduced to the crude metal. So how we reduce? For reduction process, There are 4 types based on the nature of the mineral. We can reduce the ores in chemical reduction, auto reduction like sulfide or copper sulfides, displacement method that we are going to learn in thermite process, and of course electrolytic reduction. Now let us recall what are the steps involved in this entire extraction of the metals once again. Now let us see this chart. If you get to know this perfectly, it will be an easy task for you to understand the various steps involved in the extraction of the metals right from the ore to the pure metal. See, we have learned all these things: concentration of ore and the different methods adopted for concentration of ore, that is hand picking, washing, trap, flotation, and magnetic separation. In the main stage of the extraction of the metals is extraction of the crude metals from the ore. In that, we have finished this step also. Metals of high reactive like sodium. Yesterday, we have seen the electrolysis method of sodium extraction from its ore. Now, today we are here at this stage. That is the metals of medium or moderately reactive ores, metals. They are in the form of carbonate compounds or sulfide compounds by calcination, roasting. These two are oxidation type reactions. Roasting is a kind of oxidation, and calcination is also a kind of oxidation. But there is a slight difference between calcination and roasting. You will learn all those things in detail in due course of the class. So from this oxide form, these two are converted into oxides, as I told you earlier. Then they are reduced to the metals by means of chemical reduction, auto reduction, displacement method, and electrolytic reduction. So up to this is known as a concentration of ore. This stage is known as a extraction of the crude metal, and the last one is the purification of the metal. Now let us see the next. Now let us learn about the extraction of the metals of moderately reactive in detail one by one. Based on the nature of the ore, whether it is sulfide or carbonate, we make use of a different method. The ores of these metals are generally present as a sulfide or carbonate in the earth's crust. Therefore, prior to the reduction of the ores of these metals, first they must be converted into metal oxide for the easy reduction. So, for oxidizing these carbonate and sulfide ores, they are converted into oxides by heating the ores strongly in the excess of the air. In the presence of air, the oxidation is done. So this process is known as roasting. What is roasting? Oxidizing the ore in the presence of air is known as roasting. The first step, let us take one example, that is lead sulfide. Lead sulfide is a ore of lead. It is in the form of sulfide. So in order to reduce the lead sulfide into the metal, the first stage is that we have to convert this lead sulfide into lead oxide. So oxidation is taking place in the presence of the air, that is known as roasting. We are roasting the lead sulfide to get the lead oxide. In this process, sulfur dioxide is also formed. It is in the form of a gas. So we have converted the sulfide ore into the oxide form. It is first step. Now the actual method, the important method, that is the reduction of the metal. In the extraction of the moderately active reactive metals. The first step is converting the ore into the oxide. The second one is the reduction. Now see, with the help of coke is added to the oxide, then the reduction will be easy. Here, the reduction agent is coke. It helps the lead oxide reduce to the lead. So that is why this coke or carbon monoxide are taken as reducing agents. So that means it takes out the oxygen from the compound. The reaction of the metal oxides with carbon. So we make use of coke in a closed furnace. These reactions are done in the furnaces because huge amount of heat is required. In normal conditions, we cannot get such amount of huge heat. So that is why these reactions have to be taken place only in the furnaces, where the temperature can be raised up to 2000 degrees of centigrade. So this reaction process has to be done in the furnaces. So here lead oxide, when it is combined with coke, it reduces to the lead. This is the required crude metal. Of course, there may be some impurities in the lead, this metal. Then we have to purify the crude metal. That is different case. So this is the method. The second one is, this is the first one. We have used the coke as a reducing agent. Carbon monoxide also used as a reducing agent to obtain the metal from its ore. It is iron oxide, magnetite. Magnetite is added to the carbon monoxide, which is a reducing agent. Then this carbon monoxide reduces this iron ore into iron. This is also done in a blast furnace, where the calcination and the roasting process will take place simultaneously, and of course the purification also can be done in the blast furnace. So that will we will learn in our coming classes. This is the one method, using the coke as a reducing agent and using carbon monoxide as a reducing agent. Now let us see another method, that is the auto reduction of sulfide ores. This is the third method. In this extraction, like copper from its sulfide ore, the ore is subjected to partial roasting in the air, which converted into its oxide form. Here copper sulfide is converted into copper oxide. That means copper sulfide is oxidized to copper oxide. Sulfur dioxide also evolved in this reaction. When the supply of air is stopped, what happens? The temperature rises to the high point. Then what happens? The rest of the sulfide, which remains unparticipated in the reaction, converts into oxide, sulfur dioxide. Then the left out copper sulfate again reacts with the copper oxide. Then the reduction takes place. In this course, the copper is obtained. This is called self-reaction, because the reagent itself is helped to reduce the copper oxide to the copper. Yes, the fourth one, also an important one, that is the thermite reaction. We have seen the reactive series. Using the high reactive metals, we can reduce the metals from moderately reactive ores. In this, the chemical reaction named displacement takes place. The highly reactive metals, when added to the moderately reactive metal ores, what happens? The highly reactive metals like aluminum or sodium or magnesium, they displaces the moderately reactive metals from their ores. Like in this way, we are able to obtain the metals from their ores. Here, these highly reactive metals are used as reducing agents. In earlier cases, we used carbon, that is the coke and carbon monoxide as reducing agents. Here we have taken aluminum or calcium or sodium or magnesium as reducing agents. Now, let us see the chemical reaction involved in the thermite reaction. Here, tin tandem is also a moderately reactive metal. Tin chloride, tetrachloride is one ore of titanium tin. When it is mixed with magnesium, the highly reactive one, magnesium, as you know, the highly reactive metal. This highly reactive metal displaces the titanium. Sorry, this titanium tetrachloride. This titanium, it gives us titanium, and the magnesium formed as magnesium chloride. In this reaction, what happens? A huge amount of heat is evolved. It is such a huge that the metal reduced in this process converted into molten state. The metal converts into molten state. So such huge amount of heat is produced in this reaction. That is why thermite reaction is a kind of exothermic reaction. It is a exothermic reaction. A huge amount of heat is evolved or produced in this thermite reaction. It is one more example. Here we have used magnesium as a reducing agent. Here sodium. Sodium replaces the titanium, which gives the titanium metal, and sodium converts into the sodium chloride. Two more reactions are there. Now let us see the application of the thermite reaction. The main application of the thermite reaction is it is used in the welding of railway tracks. Now let us see what chemicals are used. In thermite reaction or thermite welding, it is also known as thermite welding. The aluminum powder and the iron powder, iron oxide, both are used. Of course, 78% of iron powder and 22% of aluminum powder are used. The mixture of these two is known as a thermite mixture. So when these two are mixed up and ignited, these two have to be ignited. So the chemical reaction, it is an endothermic first. A small amount of 900 degrees of centigrade, degree Celsius heat is required to start this reaction. The reaction between iron oxide and aluminum. Iron oxide is a ore of iron, which is moderately reactive ore, metal, iron. So when it is added to a highly reactive aluminum, what happens? This aluminum displaces the iron from iron oxide to gives us the iron. In this reaction, huge amount of heat is evolved. It is such a big amount of heat that the iron in this reaction is in the molten state. It is molten. So one more thermite reaction is also there. Chromium oxide, when it is added to aluminum powder, aluminum oxide is formed and chromium also formed, and a huge amount of heat is released. So this is an exothermic reaction. Now let us see the picture that has given in your textbook exactly. These are the railway tracks, or in other terms, rails. They are broken. Then how to weld them? So this is the mold where the thermite mixture is added and ignited. Then the iron is formed in the molten state. The molten, that is in the liquid form of iron, settles down and poured and gets into the every crack or every gap of the rails, and they are here. You see in this picture the joint is welded perfectly. So this is the suitable method. Now let us see a video for our better understanding. You will see the how thermite reaction is taken place here. So this is the mold that we have discussed earlier. In this mold, the thermite mixture is added. It is fitted to the railway tracks, and the thermite mixture is ignited at 900 degrees of centigrade. Then the chemical reaction takes place, displacement reaction. This is what the white one is aluminum, whereas these two are magnetite, pulverized or powdered magnetite, and some other materials also used to fasten the reaction. See children, what is happening here? These are taken into a mold which is fitted to the rails and ignited at 900 degrees of centigrade. Then the displacement reaction takes place. So thermite reaction is nothing but what type of reaction? It is a displacement reaction. The reaction is taking place. So in this reaction, a huge amount of heat is evolved. 3500 degrees of centigrade heat is produced. At this temperature, the iron formed in this reaction converts into the molten state. The liquid form of iron settles down in the, gets into the every nook and corner of the cracks, so that a perfect welding is possible. After the process is completed, the molds are taken out and the excess welding material is ground. So grinding has to be done. So they are being removed. Now let us see how the welding is done. So grinding is done there to remove the excess material from the rails. After this process, they are looking like a new railing, new track. We cannot even find the place where the welding is done. So this is what about the effective welding, that is also known as thermite welding. So with this thermite welding, we can join the materials perfectly. Actually, this process is introduced by hand goldsmith. Now, a question arises: why thermite process is preferred to the normal welding techniques? Why it is so effective? Now, we have discussed earlier, because the thermite mix, when ignited, high amount of heat is evolved. Then what is the use of that high amount of heat? Yes, the high amount of heat converts the metal into the molten form, fused form, or liquid form. The metal in the fused form perfectly welds the gaps, perfectly gets the two separated parts in a perfect manner. That is why the thermite process or thermite welding is used. Okay, so far we have learned about the thermite reaction, that is, and also before that, the extraction of the moderately reactive metals from the ores. Okay, different reducing agents are used in the chemical reaction or displacement or thermite reaction. We have extracted the moderately reactive metals from the ores. Now, students, let us test ourselves what we have learned, how far the lesson you have received. So these questions are posed to you. Try to answer them with the help of your teacher, or you can watch the lesson again and again in the YouTube channel DCEB SURYAPET. So try to answer these questions. How the moderately reactive metals are extracted? You have to write in brief about the steps involved in that. The second question is that interesting one: why the ores are converted into oxides before reducing them to the metals? Why not they are directly reduced when they are in the form of sulfides or carbonates? So what is the thermite reaction? You have to define the thermite reaction. Students, this is very important. As I told you, in examination, the question may appear, so pay attention. The fourth one is a simple one. What type of chemical reaction is the thermite reaction? So you know about the different types of chemical reactions. So thermite reaction, which type of reaction it is? So what is a thermite mixture, and what makes the thermite mixture? Okay, students, hope you have followed the lesson very well. Now we'll meet again in our next class.